51, you know, like looking ahead to the chapter 1 test, like we're definitely going to see something that's going to challenge us to this spot. So, kind of preparing yourself, thinking about this, watching these videos, kind of working your way through, knowing when you get to this reduced echelon spot, like when do we insert that free variable, that t, into that spot, and then how do we use that? And so should be pretty consistent, so it shouldn't be a big surprise. So jumping in this, going through the steps, looking for these patterns that we're starting to see. So we're trying to see how we can maybe move things around or change things and make things simpler. So I'm just going to take on our first step to try to get the first row kind of in a more manageable situation. I'm going to take row 1 and I'm going to divide it by 2, and that's going to become my new row 1. And so that's just going to give me, and once again, I'm going to change to x. So it's going to be x plus 1/2 y minus 3/2 z is equal to 2. All right, bring everybody else down. So 4x plus 2z is equal to 10, and negative 2x plus 3y minus 13z is equal to negative 8. All right, so now I'm glancing at this in red and I'm saying to myself, okay, so like what could I possibly do to start eliminating something? And so I would focus my energy on the first and the second. And I would use that to say to myself, okay, well, I could actually get rid of this x. So I'm going to make a new row 2. And my new row 2 is going to be the sum of row 2 plus negative 4 times row 1. And so when we do that, that means we're going to take this guy right here. We're going to multiply it by negative 4, that entire row. All right, so the first row is going to stay the same. So I'm going to bring it down because I always make a mistake and like forget that. So it's just row 2 that's changing. So negative 4 in that's going to give me 0x. I like to put that there to hold my place. Negative 4 times that's going to give me negative 2. Negative 2 plus 0 is going to give me negative 2y. Multiply across that. That's going to give me negative 4. That's going to cancel. That's going to give me positive 6z. That's going to be negative 8 plus 10. It's equal to positive 2. All right, I got a mistake here. Sorry about that. And that is right here. So when I do this, this gives me, let's see that. So negative 4 times that, I get positive 6, but then I have to add it to 2. So that's not going to be 6 right there. I don't know if you caught that when I did it. That's going to actually be 8. A lot going on, huh? All right. So here we are. Bring down the last row. So negative 2x plus 3y minus 13z is equal to negative 8. All right. All looking good. I'm going to come back, grab my eraser, and just go ahead and erase this so I don't get confused by it. And now what I'm hoping that you're starting to see is you'll see that there's a possibility I could get rid of one of these rows. So maybe like my new row 3 would be equal to my row 3 plus, 2 times row 1? Would that work? Yeah, that would work, because if we did that, if we took 2 times this, those would cancel, wouldn't they? So let's bring everything down. So we have x plus 1/2 y minus 3/2 z is equal to 2. We've got negative 2y plus 8z is equal to 2. And now we're going to go ahead and distribute that across. So positive 2 times that, add those together, that's going to give me 0x. Positive 2 times that, it's going to give me 1. 1 plus 3 is going to be 4y. Positive 2 times that is going to give me negative 3, and negative 3 and negative 13 is going to be negative 16. Positive 2 times that's going to be positive 4, plus negative 8 is going to give me negative 4. Okay, so now we're going to bring this guy right here across, and I'm going to have to go to a different screen because of space. Actually, you know what? I'll just move it right up here. That'll work out great. Okay, so next step. Well, actually, let's go back. Let's get rid of that R, right? That X right there. Okay, I'll be right back. Okie doke. So here we are. We're looking at this and we're like, okay, so like what could we do here? How could we maneuver anything? And like, so maybe we're like looking at the second and the third row because they have similar multiples. And so maybe we're like, maybe we could cancel a y. All right. So if we're going to try to cancel a y, let's see. All right. So we're going to try to cancel a y. So let's see. What if we took row 2 and we multiplied it by something so it would cancel with row 3? So we're gonna make a new row 3. Okay, so we're gonna do a new row 3, and our new row 3 is gonna be equal to our row 3 plus 2 times row 2. What do you think about that? So I'm going to go back on that, just because I worked it out and I deviated from like the way that the book had worked the problem a little bit. And what that led me to is it just led to like cycling back around to other work later on, which is that insight thing, that being able to see it. So I'm going to back up here and I'm going to change my mind and do something first that's going to give me kind of some leadway down the road. And that is that I'm going to take R2 and I'm going to let R2 be R2 divided by -2. Okay, so I'm going to bring this up and rewrite it. So we have R1, so that's x plus 1/2 y. Start with that. Minus 3/2 z is equal to 2. Then we're going to take half of the R2. So a -2 and a -2 are going to give me a positive y. And then a -2 out of that would be -4z. And then a -2 out of the last one would be -1. We'll bring down the next one. So 4y minus 16z is equal to -4. Now, at this point, it makes way more sense, because if I would have gone through, and I'm going to take a minute here in this video just to kind of talk about this. If I would have gone through and did what I said, if I would have taken and said, let's let R2 be equal to, what was it? R2 plus 2 times R1, I believe is what it was. So in that case right there, no, I didn't say that. It was R3 is equal to that. So R3 would be equal to that. And so we would have some things cancel. It'd be really nice, but then we would get to this spot. So I'm just going to go ahead and do the work real quick. So that's R3 right there. Let me pull that out and just erase that. Ooh, I almost hit clear all. That would have been bad. That's R3. And that's R2. Okay, so if we would have done that, the first one stays the same. So I'd have x plus 1/2 y minus 3/2 z equals 2. And then I would do 2 times this plus that. So this is going to stay the same. So this is going to be -2y plus 8z equals 2. And then what happens is right now is that when I do this, so that would give me 0y. So 2 times this plus that. That would give me 16. That would be plus 0z. And then that would give me equals 0, which is great. But the problem is I've gotten too far ahead of myself, because now I don't have that ability to have that row echelon, because now I'm down. I don't have a 1, a 1, and a 1. I don't have that simplification down the line. I've gotten rid of all of my z, all of my variables, all my z's. Yeah, excuse me. And so this last one's equal to nothing. Whereas here, now I get to a spot where I can then step back and say, okay, well, I can get rid of some stuff. But yet I've simplified this next one down to where I've got a variable that, or 2 variables. So I say that and I'm looking at it. I'm like, huh. Yeah, so it doesn't, something goes awry here with this one that leads us down. So I'm not going to go any further with that. I'm just going to stop and clean that up real quick. So that's kind of not confusing for us. But dabble with that if you want and see how that goes. So here we are, we're over here. We're going to change color pins. Let's go to purple. So this is what we have. And so now this is a spot where we're set up where we can go ahead and say, I'm going to let R3 be equal to R3 plus -4 times R2. Okay, so the first equation comes down. So x plus 1/2 y minus 3/2 z is equal to 2. All right, my next equation is going to stay the same, so that's going to be y minus 4z is equal to negative 1. And then I'm going to take and I'm going to multiply this guy times my negative 4 and add it to that guy. So negative 4 on that's going to give me 0y. Negative 4 on that's going to be positive 16, which will give me plus 0 z's. And negative 4 and that's going to be positive, and that'll be equal to 0. So the really interesting thing is, like, as I was saying that earlier, I actually got to like a similar situation. But this one allows me to get out to what I need to be able to have those final solutions. And so at this point, we're done. We've hit our row echelon. Oh, no, we got one more thing to do. We've got to simplify a little bit more out of this to kind of eliminate one more variable. So sorry about that. So the last thing we need to do is get rid of one of the possible variables. So I think we should try to rewrite R1. All right, so maybe we're trying to get rid of, let's say, the 1/2. Okay, because that would get rid of that y out of there. So we just, on this one, we have just x's and z's. On this one, we only have y's and z's, and that allows us to do the substitution that we have with the floating variable, the free variable. So let's say we're going to let R1 be equal to R1 plus negative 1/2 R2. Okay, so let's see how that goes. So we do that. Let's see. So R1 is going to become 1/2. So we're going to take negative 1/2 right here times this guy. So the x comes down because x plus nothing is x. We do a negative 1/2 times that. We can't put that with there. That gives us no y's left over. We do negative 1/2 times that. That gives us positive 2. Positive 2 and negative 1.5 gives us a positive 1/2 y. A positive 1/2 and a positive 2 gives us 5/2. We bring down our second equation, which is going to be y minus 4z is equal to 1. At this point, to be able to kind of get like just like everything dialed, if we wanted to, we could go through. Nope, we're good because we already have this spot where we have x equals y equals. And so, oops, I see I wrote one thing wrong right here. That's supposed to be a z right there. Okay, and I apologize. This is a small space and I have big handwriting. So at this point, what happens is we come over here and just kind of actually, since you already have this in your video. Oh, no. Okay, that's unfortunate, but it's on the video, so it'll be okay. So I'll just put down, because I already have in my scratch notes. We're at the spot right now where we have x is equal to, where are we at right here? X, we don't even have x equals 2 yet. So let's just clear. We're at the spot right now where we have x plus 0y plus 1/2 z is equal to 5/2. And then the other thing we had here was we had negative 2y. Sorry about that. I'm digging through my notes. Is 1y minus 4z is equal to negative 1. And so just because I think it's like really valuable is that I am going to get rid of that so I don't get confused by it. And at this point, I can see that I have this guy solved for x, this guy is solved for y. They both are in terms of z. So they have z's in them. And so I can go ahead and move things over. So this guy becomes x is equal to negative 1/2 z plus 5/2. This one becomes y is equal to 4, sorry about that, 4z minus 1. Okay, so we come along, we're going to let z be equal to k. So that way we have one solution to this because of this idea that we don't have like this physical value. Then what we can do is we can substitute and say, okay, well, if k was equal to 1, then what would that look for this guy? So this takes us to this equation being y is equal to 4k minus 1. This equation becomes x is equal to negative 1/2 k plus 5/2. And then we have z is equal to k. So there's our free variable plugged in there. Big, long, nasty question. Working through all those steps in that process. practice, I think, is going to be the key thing to this. Becoming aware, looking for those key things. How do we know that we're there? Well, we knew we were there because we had a situation where we had an x that was solved in terms of z, and we had a y which was solved in terms of z. So we had eliminated that other scenario out of the situation. So previously, and I deleted it, I apologize, but previously the first equation had an x